Good afternoon. Thank you for inviting me to speak at MRE today. I'm just thrilled at this opportunity. And thank you to the UK Metamaterials Network for inviting me. I just wish I was there in person. Um, so hopefully my short presentation here will add some inspiration into the discussion on metamaterials. I apologize in advance that many of my comments here may come across as a narrow viewpoint from all the way over here in Silicon Valley, but hopefully you'll see that many of the things here are very much directly relevant to the similar magnificent breakthroughs that we're seeing from young technologists working in metamaterials in many of the great universities there in the United Kingdom. And I know many of you are in fact there today. So by way of introduction, we are a venture capital firm. We're based in the United States. I'm based in California. We invest money in frontier technology startup companies that take metamaterials from the lab and turn them into valuable high growth product companies. Our interests lie in building great companies that sell products in multi-billion-dollar markets. We're particularly focused on computing, communications, imaging, healthcare diagnostics, robotics, sensors. And basically, we find nascent technologies. We build the entrepreneurial teams. We fund the companies from seed stage. We bring along other like-minded investors to mentor and grow these companies into great businesses. So it would be very easy to quickly launch into the attributes of metamaterials, technology capabilities brewing in the universities around the world and there in the United Kingdom. You've already heard about some of the new technologies coming from UK metamaterials research, and I'll skip past the explanation of how metamaterials work, as Alistair and many of the people on the panel will do a much better job at that. I've been involved in building companies in metamaterials for almost a decade now. Raised a fund to invest in commercializing more than a dozen successful companies to date. It's sometimes it's important to stand back for a second and just look at the learnings from history and see it from the point of view of where every decade or so a new technology sparks multi-billion-dollar markets, whether it's semiconductors or carbon fiber or batteries or nanomaterials. We're already now living in the early phase of market development of metamaterials companies that we expect will follow the same trajectory of these other big markets of decades prior. We view metamaterials in the same way as we view nanomaterials or carbon fiber. We see metamaterials heralding all sorts of new products that are better, they're faster, they're smaller, they're more efficient, more mass manufacturable. I put this slide up here this afternoon frankly, just to make an impact statement. This is very new news. This is a relatively new company, a new startup. It's based in Austin, Texas. It's a spin out of Duke University, founded by a postgraduate student working on metamaterials. He came out of David Smith's group in the physics department. Some of you might recognize that name. He's a leader in metamaterials. So on the heels of about an $8 million seed financing, which we led a few years ago, the company just closed last month a staggering $110 million round of venture capital from the likes of Microsoft, Saudi Aramco, Bosch, many other investors, including ourselves. The company's name is Neurophos. It's building a new type of optical AI processor chip, uses very clever optical metasurfaces. You've got over 1 million elements per chip. It has staggering implications for energy efficiency, processing power when you compare it to current AI-based GPUs that are available today that you read about in the news every day of the week. There are 2 points to take away from here. One, there's no reason this cannot be replicated from a similar university here in the United Kingdom. And two, the excuse I often hear is that there's not enough venture capital in the UK or in Europe. I don't feel that's appropriate. Capital will flow across borders for the best ideas. And Neurophos, this company is a great example. Investors from Saudi Arabia, from Germany, from the US, from Japan, and elsewhere. So I want to use it as a stimulation to all. I have 3 quick slides here in rapid succession with some visuals of real companies that are well financed, all startups, many from universities. with strong applied research in metamaterials. The first photo on the left, we already talked about. We already talked about AI, optical computing. The one in the middle is a company called Lumotive. It's also, by the way, also a spin out of Duke University. They too raised over $100 million in venture capital funding from the likes of Amazon, Samsung, Swisscom, Bill Gates. They've built the world's smallest solid-state optical processor chip, which has a wide range of exciting applications in big markets in humanoid robots, data center optical circuit switching, autonomous transportation, consumer electronics. And the bedrock of this technology is liquid crystal and optical metasurface that can be built at extremely low cost using standardized CMOS semiconductor processes. These products are already shipping today into multiple markets, particularly in robots, for autonomous logistics in warehouses, among many other things. The third photo is a company called Echodyne, another startup, also raised triple-digit millions of dollars in venture capital, shipping tiny solid-state radar, which is used in military and secure applications, particularly in drones. And, all these three examples, you are allowing the building of better products that are doing the same or better as incumbent technologies, but orders of magnitude smaller, cheaper, smarter, energy efficient, and cost-wise. This other slide here I want to use are three more examples where metamaterials are shaping some really great and exciting companies, from small 5G transponders versus, what we know today, the ubiquitous, these big mobile phone towers. This is a company called Pivotal Comware. It's based in Seattle. They make tiny transponders using phased array antennas that employ this holographic beam steering technology. It has a more efficient use of 5G bandwidth. You can get more channels, more users in smaller antennas. They can produce products that are these small transponders that use low power. They're inconspicuous when you compare it to big cell phone towers. They free up the wireless spectrum and obviously bring more profit margins to carriers. The middle column is an area where we see a huge amount of product development in flat surface optics, we sometimes call fat optics, where metamaterials replace conventional glass lenses to make displays smaller, more immersive, cheaper. And there's a whole long list of companies from Meadowlands, 2Pi Optics, Fourier, and Israel, that we see a huge amount of investments here, also in China, all using optical metamaterials. And the third column I added to highlight an interesting company with metamaterials, which is spun out from Airbus in France, actually. A group of entrepreneurs from that company, started this company, which exploits some of the physics of acoustic metamaterials to allow private, seamless communications on the go without others hearing your communications. If you're having a Zoom call on the train or somewhere down the road, we expect with the advent of Starlink to see more voice telephony on airplanes. Again, all three different companies with different ways to integrate metamaterials into smaller, smarter, immersive products. And the last example I'd like to highlight is a very fascinating company in San Jose, California. There's a group of engineers and researchers from Harvard University, some team members from Boston Scientific, Johnson & Johnson. They set about making a new type of imaging system to go deep down into the lung tissue during bronchoscopy procedures. And the company adopted a very novel idea using metasurface optics and metamaterials, making them so small that it allowed a catheter to go deeper into the lungs when you compare it to current ultrasound technologies. This is what you would see in today's hospitals for bronchoscopy. So deeper into the lungs. But, any of you who know anyone who has been diagnosed with lung cancer will note that this is the deadliest cancer that kills more humans than any other cancer diagnosis. By the time a problem is detected, it's often too late. And its detection being the operative word here. This novel approach by this company, Lead Optic, they allows them to put both the biopsy needle and the imaging system together, both of them together into the same catheter because they're so small, using metasurface optics. And today, if you go for a bronchoscopy, an imaging system is sent down into the lungs, it's then withdrawn to make room for the biopsy needle, and that often results in misdiagnosis or worse, like unnecessary bleeding. So Lead Optic this January just achieved FDA clearance and has already started conducting human trials in one of the largest hospitals in the United States that treats lung cancer. And again, this is just a great example of a great product using the magic of metamaterials. And most importantly, this is a product that will be used to save just countless lives. I'm almost at the end here. This slide could very easily be replaced by a similar fantastic education research institutes list from the UK. All those great universities that lead in metamaterials like Imperial College, Exeter, Cambridge, Leeds, Warwick. The list goes on and on. I also I want to note the strength of the community in the UK. The UK Metamaterials Network now has over 1,000 members and has brought the community together really magnificently, acting as a single voice representing academic, industry, and government. It really is an amazing organization. But anyway, I put this slide up to show you some of the successes that we've had as an investment firm in spinning out and funding companies from these universities listed here, which happen to be also great sources of breakthrough metamaterials research. By the way, that photo in the background is Professor Rain Zhang of the University of California in Berkeley. We recently just funded a spin out from his lab, working on haptics, sensory technologies using metamaterials that will go into humanoid robot hands. And these allow the sense of touch, which is now becoming a more and more critical component in robotics. So to end, I thought I would just maybe summarize in the sense of, what we see from 30,000 foot level, and perhaps, give some directional inspiration here, highlight some of the competition, some of the competition forces that are out there, and encourage development areas where the UK is particularly strong in metamaterials. AI is hot. I think I made that point earlier. Optical computing, optical circuit switching in data centers. This is just a huge area of investment globally as companies are racing to build out more efficient data centers. So anything that can impact electricity use, cooling, speed will be fair game for the next few years. Life sciences is very interesting in diagnostics. Diagnostics and therapeutics. I gave an example already in the diagnostics side, but also in therapeutics, we see a huge amount of activity with startups using metamaterials, particularly in spectroscopy for new protein and new drug discoveries. If you're looking to raise capital for your idea, go talk to big companies. There are many corporate venture arms investing heavily in metamaterials right now. We've seen and experienced great examples with Merck. They have a venture arm called M Ventures, Sony, Applied Materials, Murata, Bosch, many others. I could go on and on. And many of these companies have co-invested with us in some of these early stage startups. China, there's a lot going on there in metamaterials that is not going to pop up in your Google search. We see immense investment in metamaterials, particularly optical metamaterials. And even in the academic world, if you look at the number of papers and the number of patents that are being written in China, we're clearly seeing there's a vector that's going to surpass what's happening in the EU, in Europe in general, and in the United States. So again, something to watch. But again, all leading to the same conclusion that metamaterials is a hot, exciting space right now, very competitive, and a huge amount of innovation going on. And lastly, an area which we've not invested in yet, but we want to, and this is an area where the UK, I feel, has a particular edge. We see a lot of acoustic metamaterials intellectual property in the universities in the UK. That's very exciting, waiting for that right postdoc student to go out and start a company. Acoustics has huge applications in data centers, seismic management, sound control, in space launch vehicles, which we didn't have much time to talk about today. Space is a huge market, huge investable market right now. So that's where I leave it here today. I think in some parting words, I would recommend that the UK Metamaterials Network really seize this time to make investing a priority. There's clearly no shortage of intellectual property, of talent, great ideas in the UK. This is a wonderful time to invest in creating great companies, create jobs, create a leadership position in an area where the UK has just so many strengths. So with that, I thank you for inviting me today, listening to my comments, and I hope these were helpful and inspire you to go start your own company.